Hello, everyone. I hope you folks can all hear me. I'm Sundar Krishnamurthy. I basically manage application and cloud security with Expedia Group in Seattle, Washington. But to tell you the truth, I'm sleepless in Seattle thanks to all the crazy things that developers, technical people, managers, all those that do with implementing systems, software, security. And for me, the talk that I have today is all about envelope encryption, the proverbial silver bullet. You can say all data is always encrypted, right? It's obviously true. Whenever you have a breach and the auditors or the law enforcement asks, was this data encrypted? You say, yes, it was ROT 26 encrypted, and you give them a smile. They won't understand what you're talking about. But I hope this talk would be more entertaining. I'll give you some bad jokes, not so bad jokes. And please glare at me, give me comments if you think my jokes stink. Most of them they do. So I'll make certain I give you good ones. So let's get started. Envelope encryption, the proverbial silver bullet. So let's see, what are we going to talk about? We're going to talk about the fact that most companies around the world today go to extreme lengths to make certain they guard PCI data. PCI is basically payment card industry. So what the payment card industry essentially do is they make certain credit card numbers are tokenized, they're encrypted. You use double, triple encryption. You've got systems that are not accessible from any networks. You don't go to insane lengths to protect cardholder data or CHD. But what about PII, which is personally identifiable information? What do you do to protect that data? Some companies say we protect that, other companies say we encrypt that. But the GDPR clause is very clear. They say encrypt everything. So my talk is going to be mainly about encryption. So personal data, PII, is covered by many clauses, like you have GDPR and CCPA. Like the joke is that GDPR is a 4-letter swear word. It indeed is. So that is the Global Data Protection Regulation from UK and Europe, and CCPA is basically California's privacy law. Both of them say PII must be secured. It must be not accessible anywhere. And if you get breached for GDPR, CCPA, you are going to face hefty penalties. So the problem's hard, and we're trying to solve it the easiest way that we can do it. So dev product teams were never taught the right methods to protect this data correctly. And the best method to protect, according to me, is encryption. Encrypt everything. Encryption will get you to a very good place. But how to do it will be the focus of this talk. Usually what teams do is insiders are given a lot of power and privilege with the implicit assumption that they will work in the best interests of their product, brand, platform, or whatever is their startup idea. They're going to work in their best interest. But you give too much power to these insiders, to these people. Like I was working at a startup many years ago, and the thing was like there were 40 of us on the team, and all 40 knew the usernames and passwords to production, all 40 of us. That wasn't a very nice place. At the time, I wasn't in security. I was like a startup software engineer, but now I think outside the box, and I'm like, that was crazy. We should not be doing that. So the last point is logical and physical access controls differ for most teams. They probably never engage security teams in their design or built out. So security always gets called in the end. Like we folks, security architects, engineers, managers, professionals, we get called in like, hey, we want to launch in 2 weeks. Can you please dot all the I's, check all the I's are dotted, T's are crossed, put check boxes and just tell us we can launch? And we say, no, you can't. You called us so late. We're going to perform a threat model. We are going to see what are all the gaps that exist in your system. What are the ways via which your insiders, outsiders, anyone can compromise your system. We're going to go deep into it. So we've got to come and make certain we grab our arms around this. So the thing is, we need to move to a better place, and we say encrypt everything that is stored at rest unless public. So that should be the tenet, a mantra, a holy grail for us. So the first bullet point very simply is there is no law anywhere we know yet which states you cannot encrypt certain kinds of data and must be stored plain text. Why did I write China in a small, the question mark there? China is basically a country where any data that's encrypted inside China, you must escrow the encryption keys with the Chinese administration. The concept is that the Chinese need to have the ability to decrypt any and every data inside their network, inside their country, inside their systems, and view it plain text. If they can do it, you're not allowed to do encryption in China. That's the only caveat. But other than that, if you encrypt data everywhere, you're good. Like I knew of this weird use case. There was this team. What did that team do? They were storing orders for countries around the world. And apparently there is some law in Malaysia, Indonesia, and some ASEAN countries that says PII must be encrypted at rest. So what did this dev team do? They were looking at the order countries and then checking. If the order is Malaysia, Indonesia, or Singapore, we will encrypt it. If it is any other country like India or Pakistan, we are going to leave it plain text because these countries have no law. And I'm like, this is stupid. This is ridiculous, was my feedback to the team. I just asked the team, what will happen tomorrow if India come out and say our data must be encrypted at rest too? The team was like, yeah, we're going to write a program. It will go to the database, find every record which is plain text from India, and we will encrypt it. I'm like, all this is a waste of time. So my point was just encrypt everything at rest. You need not check if it's India, we encrypt. If it's Singapore, we encrypt. If it's not, then we don't. Don't do that. It's overkill. Just encrypt everything at rest. So that would be the best way out. And most importantly, one buzzword you keep hearing across all security podcasts and conferences, everything is zero trust, the zero trust infrastructure. So when you come to the zero trust model, it's all around encryption. But my talk is going to be more around key management, and that is going to be what is the crux of the problem here. If you manage your keys nicely, encryption is there. But if you don't manage your keys, you have a big problem. So the problem is that we have vague and snowflake encryption patterns. That's what. A lot of times what is happening is you would say it is very secure because teams are using AES 128 or AES 256, or teams are using RSA 2048. It is secure. Then I ask the team, where is the key? And they say the key is actually a file that is checked into GitHub. And I'm like, all bets are off. GitHub is no place for you to store a key. Your key should ideally be inside a key storage mechanism. Right? So what a lot of teams do is they say we are going to perform encryption, we are going to use good algorithms, but we are going to take the key and we are going to put it in secrets manager, AWS secrets manager, or the teams are going to place it in HashiCorp Vault, which is another good place to store secrets. But then HashiCorp Vault and AWS secrets manager are great place to store credentials, passwords, API keys, database connection strings, but not encryption keys. That's a completely wrong way to do it. It's like putting a square peg in a round hole. It won't go in. So what the basic problem is that there is no key rotation mechanism in place. There are no logs for encryption, decryption tasks. So you don't know that key has been used to encrypt how much data, or what were the mechanisms that you had. If the key has ever left that secret storage, we don't know. So teams have been doing this wrongly in the past. They need to change. So a lot of times what teams did was they encrypted by hand. In the sense, what I'm trying to say is they're not going to come up with their own encryption algorithms, essentially. That's not what I mean encrypting by hand. So what I'm trying to say is teams are using encryption libraries like Bouncy Castle for Java, or the Microsoft DP API, and so many other mechanisms that exist. But the problem is that nobody managed these keys. So what would happen is keys would be checked into a secrets manager or HashiCorp Vault. And then what would happen when one of those people leave the team? Say if one of the admins who quits the team, do you have any governance mechanisms to know that person went to secrets manager, logged in as an admin, copied over the encryption key that's used for all your data, and he quit the company? Do you have any governance there? You don't know, right? It's a hard problem. So that's why we tell that never maintain keys by hand. Ideally, there should be no humans who should ever have access to keys. If you can take yourself on the holy grail path there, you're in a much better place. So some developers check in GitHub keys into GitHub, and then they say they're saving costs because instead of going to secrets manager and getting billed for every call, they're making one call to GitHub and getting the keys. Answer is no. It's completely wrong. So simple tenets we need to adopt. All encryption keys must live inside a secure purpose-built device, which is called a hardware security module, or HSM. It can generate runtime encryption keys for you to use. So you have a device. It's like a card, or it's like a proper vault. It's a server that's going to be installed on your network. What would that server do? That server's ability is to generate encryption keys for you. So you can take those keys and encrypt data with it, right? So the two ways to which it would work is you can either import encryption keys one time from the outside. You can push in a lot of encryption keys, or if you don't want to go that route, you would rely on it to generate encryption keys within itself and keep handing that out to you for you to use. So since we're going to look at AWS here with my example, I hope the demo gods are good upon me. I have 10 minutes that I've kept in the end for going through that. We'll go through that. So the two examples in AWS are, you have one service called AWS KMS, which is key management service. It's super cheap. It's shared across many customers. So AWS would have thousands of customers sharing keys on one device, which is good for them. And the second one is Cloud HSM, which is way more expensive than KMS because it's a dedicated FIPS 140-2 level 3 compliant device. It means one device can only contain keys of one company. No other company, organization should ever have keys inside a HSM that is dedicated. So here is where envelope encryption, 10 minutes into my call, I come to it. So what does envelope encryption do? There are two separate things in envelope encryption. One is called a master key. The other is called a data key. In the past, this was called master key, but I think we changed. We never use the word master database, slave database. All those words are gone. So now instead of saying master key, we say it's a managed key. So the managed key lives in KMS. What can that do? It can generate data keys for you, and you encrypt data with your data key. So there are two keys here, a master key or a managed key and a data key. They're two different keys. This is very different from asymmetric encryption, where you have a public key and a private key pair as what you have in RSA 2048, El-Gamal, elliptic curve cryptography, or perhaps X59 certificates. That's a completely different asymmetric. Here, both these keys are symmetric. They're unrelated to each other. So our two keys exist with three acronyms. They're called CMK, DEK, and EDEK. There are two keys with three acronyms. Let's see what they mean. CMK stands for Customer Managed Key. It's a HSM resident AES 256 symmetric key that can only encrypt 4K bytes of data. That's it. It cannot encrypt anything more than 4K. So if you have a 10 TB database, you'll be wondering, how do I use a CMK for it? The answer is you don't use a CMK. You use a DEK. A DEK is also called a KEK in the Microsoft Azure world or in the Google world. They call it KEK. AWS calls it DEK, which stands for a data encryption key, a random piece of encryption material, AES 256 32 bytes, that you employ, but it must never be saved or logged anywhere. So what we tell developers is, whenever you're going to get this key, take the key inside the function. It's a auto variable or a stack variable. Use it to encrypt your data and then toss the key away. Don't move the key to a object reference or store it anywhere on the heap, because if you have a core dump, the keys are exposed to the world. And the third one is called EDEK. EDEK is the encrypted data encryption key. So it is the DEK encrypted with CMK. This must be saved along with the encrypted data or ciphertext. All this might be sounding Greek and Latin to you. I'll show you in my demo how simple it is. This is how the whole thing works. Create a primary encryption key or employ an imported primary encryption key within the HSM, K1. K1 lives inside the HSM. K1 can never ever leave the HSM. There exists no API, no mechanism. Probably the Mossad know about it. No one else does. You cannot get K1 outside of the HSM. It lives inside the HSM and it will always live there, period. Now, what do you want the HSM to do? You want the HSM or the shared HSM, which is KMS, which is shared across all customers, to say, get me a key. So you have a generate data key API, which gives you two keys, or it gives you two entries. One is K2, with what you will encrypt your data. And the other one is K21, which is K2 encrypted with K1. So you take K2, encrypt your data with K2, toss it away, and save your ciphertext along with K21. K21 is K2 encrypted with K1. Now, whenever you want to decrypt the data, you give K21 back to AWS KMS or the HSM and say, please give me K2 back. It will verify whether your IAM user has permissions to KMS:decrypt for that CMK, customer managed key, inside HSM. Do you have the rights authority? If it says you do, then it would decrypt it and give you K2 back. What do you do with K2? Take K2, decrypt your data with it, and you have it plain text. This very simply is envelope encryption. So how does this improve our security? It's very simple. There is no risk of CMK data leakage, as nothing else should ever get saved outside. the DEK should be tossed right away after encryption or decryption, never logged to memory, never written to disk, never logged anywhere. If you log the DEK anywhere, that developer is going to get a pie thrown on his face from me. Let me know. If you know of someone who's saving the DEKs outside, I'm going to call them up late in the night and I'll threaten them in an Italian accent so they don't do it. So you can enforce policies. Only certain users are allowed to encrypt. Others can only decrypt, and all events get logged. So if the encrypted data encryption key, if K21 gets stolen by a hacker, you're going to save K21, right? If K21 gets stolen by a hacker, he would never be able to use that to decrypt your ciphertext because he does not have the permission to go to KMS and say, give me K2 for this K21. He probably doesn't have that IAM user permissions or policies or rights in order to do it. So key rotation is very accomplished very simply by re-encrypting K21 with the new K1. So it is the difference between this. You're boiling a spoonful of water. To rotate the encryption key, you're rotating the encrypted key. So 32 basically bytes of data is going to be re-encrypted rather than encrypting a 30 TB file. A 30 TB DB backup, which is backed up by a key. If you say you've got to decrypt it and re-encrypt it, you're looking at a many $1,000s worth of EC2 processing power from AWS, because to decrypt a 30 TB file to plain text and then encrypt it with another key, it is boiling the Mediterranean Sea. But then if you're going to re-encrypt K21 with a new K2, it is beautiful. You don't have to worry at all because K21 encrypted with a new K2 is boiling a spoonful of water rather than boiling the Mediterranean Sea. And you get compliance out of this. So set up automatic yearly key rotation within your HSM. It will maintain a train of expired keys for decryption for older data that was encrypted. And data custodians or compliant personnel can be granted a re-encrypt permission. They can only rotate the EDEK. They cannot encrypt data. They cannot decrypt data. They can only rotate the key once every year. So you have compliance. And there is no risk of key leakage ever unless developers do stupid mistakes that can be mitigated via secure code reviews and education. And encryption is available as a service right now. So AWS offers this service called SSE-KMS, which stands for server-side encryption using key management service. Other cloud services have also embraced this design pattern, and it's available across GCP, Azure. And the best thing about SSE-KMS is that no code needs to be written. You just have to create a CMK in KMS and then go to the CloudFormation templates or Terraform scripts for each of your AWS services like S3 buckets, DynamoDB tables, SQS, SNS, DocumentDB, Kinesis streams, Aurora PostgreSQL DBs, even EBS, which is the Elastic Block Storage, and just say, I want to implement SSE-KMS. And AWS does all the magic for you. So AWS is offering envelope encryption as a service and calling it SSE-KMS. It's part of the WAF, which stands for Well-Architected Framework, not the Web Application Firewall. WAF is Well-Architected Framework. It's one of the architectural best practices from AWS. It's a tenet. So I'll just go over these points because I have a small demo I need to run in the next 12 minutes. Never use secret storage systems like HashiCorp Vault or Secrets Manager. Establish a pattern where only service accounts have the ability to encrypt and decrypt. No human should ever have the ability. So this is known as HOSM, which is hands-off secrets management. You make certain that humans have no ability to view any data outside of dashboards. You can view data on dashboards, obviously, which is logged and everything, but you can just go to a summary to a database and say, select star from credit card table. You can do that. So audit all your secret stores, audit GitHub, and find out dev teams who have done encryption wrong and make them learn envelope encryption. It's very simple to do. And PCI DSS auditors love envelope encryption. It might form an important prerequisite in the forthcoming PCI DSS v4.0 that's going to come out sometime soon. So what you can do as a good engineer is you can take a set of keys, push them into AWS push them into AWS KMS and Cloud HSM. You can push them into your own HSM, into GCP, and then you have the same set of encryption keys everywhere. So if one of those services were to ever go down, you could go to another service and decrypt your data. You're not like a cockroach upside down with the 6 legs in the air, unable to turn itself back up. You don't enter that scenario. So here comes my dirty demo. Thankfully, I have 11 minutes to run through this demo. So very simply, let me know if you folks can see my terminal here. So I do a clear, I do an ls -l, I see there is nothing. Oh, there is lots. I just tested it. So let me do an RM star. I just tested this out. Yes. Yes. So the whole one, I have backups for all of this. 1 minute. Let me go back here. Demo gods be benevolent upon me. Yes. Delete that Sundar one Pem. I think I just kicked myself in the foot. Just give me a minute, guys. Just give me a minute. I can do it here as well. Clear AWS config. Can you folks see my screen here? Can you folks see my screen here? I think I just shot myself in the foot. I deleted the key by mistake that I have here. So basically, I'll just go over this, what I was planning to do. Let me just go back here. You folks can see my screen again. Here, AWS. Yes, the command is working. So what I basically do is I do vi secret.txt. I say secret sauce 101 :wq. So I've saved this file. What I'm going to do right now is I'm going to create a key in KMS. So I say AWS KMS create key region US West 2 description sample key for besides YVR. It created a key for me. So there are two very important things. This is how you create a key. The first thing you do is you grab the key ID. This is the most important thing. Copy. And then you come back here and then you create an alias for the key. So you see sample key YVR. I'm going to give the name. Copy. Paste. Sample key YVR and alias is created for this key. The next step that I'm going to do is I'm going to generate an encryption data key using the KMS key I created before. So I say AWS KMS generate data key ID is sample key YVR, key spec is 256, encryption context. This is a encryption context is a string you must always provide. This is how you make certain the hacker who steals your key will not be able to abuse it because the encryption context would not be on. I'm saying projects besides YVR. Here is my key. There are two separate parts in the JSON blob. First is the ciphertext blob. This is K21. It is K2 encrypted with K1. I have to copy paste this because I need this. So I'm going to just paste it here. And the other and the most important thing is plain text. This is your encryption key, 32 bytes. This is the key with which the data is going to be encrypted. Copy, paste it here. What I'm doing here is just for the demo. Otherwise, you should never be pasting the key anywhere. Humans shouldn't be able to do this. So what I basically do is I take this particular text, copy it, and I give it to the echo command to base 64 decode it into a file, encrypted key plain text. Copy this, paste, files there. Now I take the plain text key, copy it, plain text data encryption key, base 64 encoded, copy this, paste it. Now I have these files. Now here is the most important thing that I need to do. I use the OpenSSL installed program to just simply say OpenSSL encrypt, -e is encrypt. using AES 256. The input file is secret.txt, which is my secret sauce 101 file. Out is an encrypted secret.txt. And the key file is fileb:// I have to change this path because I was in the AWS instance that I actually shot myself in the foot. I have to change this to say users source repos. I just make certain this works. Okay, it worked. So now if I do a cat encrypted secret.txt, you will see this is the encrypted file. So this is my secret sauce 101, which has been encrypted with my file. The file that I used for encryption is basically the secret.txt is the input file, and data key plain text is what was used to encrypt it. So next thing, most important thing I need to do, delete the secret, delete the data key plain text, and then do an ls-l. So what files do you have? You have a file called encrypted secret.txt. You have a file called encrypted key plain text.txt, right? So encrypted key plain text is DK1, K21, and encrypted secret is my cipher text. Now, how do you decrypt it? I still have 4 minutes. I can run my decryption part very simply. Paste. AWS KMS decrypt. The encryption context was project is besides YVR. This is the secret string I told you about. Encryption context should be your secret string. The ciphertext blob is this file, and I've again got to change the path because I shot myself in the foot with the EC2 instance. I'm going to using my local one. So I say users source repos decrypted. So what did it decrypt? It decrypted my K21 and gave me the plain text K2. So this is the key with which we encrypted. So I copy this and I say paste it here, and I say paste that particular K2 here into this file. Paste. And this is our OpenSSL command to decrypt the file. Copy O, since the O did not come out, and I again have to change the path. secret1.txt. Now if I do cat secret1.txt, secret sauce 101. And that is my demo. I still have 2 minutes for questions. If you folks can ask me any sort of questions. Do you have any questions, folks? We're almost out of time. That was my demo, guys. The demo guides were fine. Instead of running it on my EC2 instance, I was able to run it on my MacBook because I shot myself in the foot and I deleted the SSH key that I had. I was thinking I was already on the EC2 instance. So that RM command was me shooting myself in the foot, and this demo was running it on the MacBook. Thankfully, everything saved. And most importantly, the last thing that I want to show you before you guys drop off is these were all the commands. These are all links that I have. And please note down this one. If you folks can take a print screen or something, you would get my entire slide deck at this bit.ly link. If you can note this bit.ly link, please do. Thanks, everyone.